Chapter 5, Lesson 8, Solving Equations by Factoring and Problem Solving. After factoring is done, what we have created is a way to solve for the x-intercepts of our quadratic function. So remember, in our quadratics, the shape of those quadratics is a parabola. And when we are solving by factoring, we are actually solving for these x-intercepts here. So when it says just factor before, we were just setting up our parentheses and finding the numbers that multiply to be 12 and subtract to be 4. So we're going to start doing that the same way. So things that multiply to be 12 and subtract to be 4 are 6 and 2. And then using my sign chart, the bigger one gets a negative. Now this time, we are setting these parentheses equal to 0 because when we find x-intercepts, no matter where they are, it's always a number, comma, 0. It's like this one might be 3, comma, 0, and this might be negative 3, comma, 0. So that is why we set our equation equal to 0. So the first one I'll solve is x plus 2 equals 0. Subtract 2 to both sides. And there's my first x-intercept. And the second one, x minus 6 equals 0. Add 6. And my second intercept is 6, comma, 0. So this parabola, if I was going to graph it, would cross at 6, comma, 0 and negative 2, comma, 0. On the second one, it starts with a leading coefficient, so this would be a window method. So I'm going to start with 2x squared here, negative 5 here. Those multiply to be 10. So what are factors of 10 that subtract to be 9? 10 and 1. Sign chart says the bigger one gets a plus. So these have in common x. These have in common 5. These have in common 2x. And these have in common 1. So my factors are 2x minus 1 and x plus 5. I'm going to set those equal to 0 each. So 2x minus 1 equals 0. Add 1. Divide by 2. So my first x-intercept is at half, comma, 0. X plus 5 equals 0. Subtract the 5. And my second x-intercept is at negative 5, comma, 0. On these examples, it says that we need to watch for ones that are not in standard form. So again, the standard form is ax squared plus bx plus c equals 0. So in example 3 here, the first thing I would have to do is subtract the 4 to set this equation equal to 0. Now this one would also be a window method because of that leading coefficient. And 2 times 4 is 8. So I'm looking for factors of 8 that subtract to be 7, which are 8 and 1. Sign chart, bigger one gets a negative. So these have in common x. These have in common negative 4. These have in common 2x. These don't look like they have anything in common, so we at least have to give them a 1. So my factors are 2x plus 1 and x minus 4. Solving the 2x plus 1, first I would subtract 1 to both sides, then divide by 2. So it's negative half, comma, 0. And the other one I would add 4 to both sides. And so its intercepts are at 4, comma, 0. On the second one, again, it's not set in standard form. First thing I would do is distribute here. 3x squared plus 14x. And I would also need to move the 8 to the left, so I would add it so that it was all equal to 0. Another window method, 3x squared plus 8 is 24. Factors of 24 that add up to 14, 12 and 2. Sign chart says they're both plus. These have in common 3x plus 2 and x plus 4. So when I solve this 3x plus 2, I would subtract the 2 and divide by 3. And the other one I would subtract the 4. Our last one here we have, not a last one. This one we have here, as far as these go, is a fractional problem. So I'm just rewriting it here so that you have it written nicely, since my program won't let me write fractions very well. And what we can do here is we can get rid of the denominators by making them all the same. So I would multiply them all to be 20. So I'd multiply this one by 5. Whatever you do to the bottom, you must do to the top. I'd multiply this one by 4. And once I have 20, 20, 20 common denominators, I can cross them out. So my equation now is x squared minus 5x plus 4 equals 0. Not a window method, which is nice. So I just start with x and x. Things that multiply to be 4 and add up to 5 are 4 and 1. Sign chart says both minus. So solving this one, I would add 1. And solving this one, I would add 4. An Alpha 3 model rocket is launched from the ground with an A-8-3 engine. Without a parachute, the height of the rocket, h, at time t seconds, is approximated by h equals negative 16t squared plus 144t. Find how long it takes the rocket to return to the ground. Well, based on what we know about the picture of a rocket being projected, is it would be launched up and then it would come back down. So also the clue that gave that away was that I have a negative 16t squared. And when an equation starts as a negative, we know that it is an upside down from whatever its normal graph is. So our normal graph is a parabola upside, looks like a U. So this one, because it's negative, would be upside down, looking more like an N. So I need to factor this thing. This is only a binomial. So what I'm looking is, do they have anything in common? I'm going to hope that 144 divided by 16. And it does. So I'm going to take out a greatest common factor of negative 16t. So if I divide this by negative 16t, it would leave me with t. And divide 144 by negative 16 is negative 9. So if you look back real quick, that would give you your negative 16t squared, and this would give you your positive 144t, and set them equal to 0. So set the first one equal to 0 and the second one equal to 0. Divide both sides by negative 16. So my first intercept is 0, 0, which we knew because it starts from here and then it's shot up into the air. This one I'm going to add 9. And so my second intercept is 9, 0. So my question is, how long do you think it will take for the rocket to return to the ground? 9 seconds. And I know my label is seconds because up here it tells me seconds is the time. While framing in addition to an existing home, a carpenter used the Pythagorean theorem to determine whether the wall was square. That is, whether the wall formed the right angle with the floor. He used a triangle whose sides are 3 consecutive integers. Find a right triangle whose sides are 3 consecutive integers. So back in chapter 3, we talked about consecutive integers. So if the first one is x, the next one is x plus 1, and the third would be x plus 2. Now, the Pythagorean theorem says to take the two sides squared and set it equal to the hypotenuse squared. From geometry, remember that this would be the hypotenuse. So this would be A, this would be B, and this would be C. So for A squared, it'd just be x squared plus B squared equals C squared. Now I want to set it in standard form, so I'm going to have to do a lot of foiling here. So this one will be fine, leaving it as x squared. Remember that squaring something means to multiply it by itself. And then I'm going to bring down this x squared, FOIL these real quick. X squared plus 1x plus 1x plus 1, x squared plus 2x plus 2x plus 4. Then combine like terms. 2x squared plus 2x plus 1, 1x squared plus 4x plus 4. Set it equal to 0, so I'm going to subtract the 1x squared, subtract the 4x, and subtract the 4. For a final answer of x squared minus 2x minus 3 equals 0. Now that we've done all that, we can finally factor this, and it does not have a window method. So what are things that multiply to be 3 and subtract to be 2? 3 and 1. Sign chart says the bigger one gets a negative. Solving that first one would give me negative 1, 0. And solving the next one would give me 3, 0. And since this is a word problem, I'm not going to want to use the negative answer. I want to use the positive. So if this side is 3 and they're consecutive integers, this would be 4 and this would be 5. A gardener has a rose garden that measures 30 by 20 feet. He wants to put a uniform border of pine bark around the outside of the garden. Find how wide the border should be if he has enough pine bark to cover 336 feet squared. Well, we need to know how long this entire border would be. So I know that this much of it is 30. And then I have this here, which is x, and this here, which is x. So that would give me a total of 2x plus 30. This side, this much of it is 20 plus x, 2x plus 20. And we are doing area, so I need to multiply them. But I do not want to cover this area with pine bark. So this area would be a 30 by 20, which is 600. So I'm going to subtract out 600 from my total. And I have enough to cover 336 feet. So I'm going to FOIL 4x squared plus 40x plus 60x plus 600 minus 600 equals 336. Combine like terms, plus 100x. Those two would cancel each other out, but I also need to set it equal to 0, so I would subtract 336. I know they're going to have a greatest common factor of 4. Hopefully, 336 divided by 4 is 84, which is good because now this is no longer a window method. Factors of 84 that subtract to be 25, 28 and 3. Sign chart says bigger one gets a plus. So this one would be 3, 0, and this would be negative 28, 0, which I won't use because I only want a positive number. And it says find how wide the border should be, and the border is X, so I only need to have 3 feet. Okay, and the last part is just going to be looking at graphs here and matching them to what they belong to. So in this first one, this would be 3, 0, and negative 2, 0 when I solve them, which is B. This one, I have x equals 0, negative 2, 0, and positive 2, 0, which is C. And this last one is 2, 0, negative 2, 0, and this 1 belongs over here. So 1, 0, which is A.